So in the third part we talk about the wireless security. So for wireless security here, as we said, in 802.11b came up with WEP, or what we call wired equivalent privacy. Okay, so this was the first primitive security protocol for wireless, and that was only based on like some passphrase, and that's it. Okay, so if the station, if you connect for the first time, then we ask you to write the passphrase. If the passphrase is correct, of course, we can do that through some, as we said before, you don't have to send the passphrase through plain text, but what we do is that we generate a pre-shared key based on this passphrase, and the station sends a puzzle with this pre-shared key to the access point, and then the access point can verify or authenticate the station based on whether this pre-shared key is created correctly, which is based, of course, on the passphrase, right? On knowing the passphrase. So if the passphrase is correct, the access point can decrypt the puzzle and can verify the station. So it's very, very easy. But we'll talk about the problem here. Okay? Then, of course, as we said, 802.11g came with, when I say came with, it doesn't mean that it's part of the standard, right? So it's around the same time. So when they came up with when the subgroup of 802.11, okay, G came up with the standard for 11G. The security subgroup they came up with around the same time. They came up with like a software upgrade or a software hack to WEP, because it turned out to be highly breakable, easily breakable. So they came up with WPA, and we'll talk about the difference for WPA. And then in a later stage, they came up with 802.11i, which is a complete wireless standard, which leverages it's a hardware upgrade, of course, but it requires the use of wireless access network access control security, which is what we talked about, which involves the use of 802.1x and the extensible authentication protocol, right? So these two did not use that. These two did not use the network access control security in any way. So they have used their own security authentication mechanism, okay? But in a later stage, they combined this security authentication mechanism with the 802.1x and the extensible authentication protocol to perform the authentication in a holistic way. Okay, so that one is really highly secure, okay, and this one is not breakable easily in that case.
Does it mean that the implementation of security mechanisms in hardware is more stronger than implementing this security mechanism in software?
لا that doesn't mean this. لا هو الفكرة إن هو the use of extensible authentication protocol and the 802.1x would not be done easily using like a software patch or a software upgrade like this. لا it requires like some hardware upgrade, because there has to be like some kind of you're right in a way, a chip or something that performs this authentication, which is built على network card, right? So that's how the wired devices they do it. Wireless devices they actually perform 802.1x and extensible authentication protocol. That's actually built on the wired card, Ethernet card, right? So that also had to be done the same way. So you have to have like some kind of hardware upgrade, both on the station and the access point. Okay, and of course the authentication server as well. So you have to have authentication server, and remember the authentication server uses different authentication mechanisms, whether it's TLS, IKE. We talked about this, right? So all of these components have to exist. Okay. for these two, we didn't have to do that. We didn't have to have authentication server. We didn't have to have all these complications, right? But here, we have to do this. In this case, we have to do this. So just in brief, of course, one thing we notice here is that for wireless, because of the channel impairments, there is a motivation for implementing like some reliable transfer with some not only error detection, with some error correction due to the high possibility of error. Due to this high possibility of error, and that's why in the assignment we motivated that by saying like if we're talking about wireless or طبعا this channel model that we have in the assignment kind of simulates channel impairments where you have like some probability of error, high probability of error. In wired, of course, the probability of error is really small, okay? But when you increase the probability of error, we have all, I hope, we have all seen the effect of this on the security mechanism, because especially for block ciphers, right? So block ciphers were really, really sensitive to any kind of a probability of error. But for wireless, there is inherently some high probability of error, right? And that's why what type of cipher do you think is fit in the wireless domain? Huh? RC4 برافو عليك. Yes شفت بقى واحنا we came up with this conclusion because of our analysis. So yes, so RC4 seems to be more robust when it comes to errors, right? And in wireless, because of the high probability of error, at the beginning they said, okay, so we need to use RC4, but really RC4 itself, as we said, it's not robust in terms of security, صح? RC4 itself, because it's based on what? It's based on Vernam cipher. It's very simple. So the and we'll talk about the high level picture of all these protocols, and then we'll get to the details of this. So we're talking here basically about one basic service set where you have multiple stations, right? And these multiple stations, they need to authenticate themselves to an access point. Okay, so what WEP implements in terms of security for authentication. So WEP here says, okay, so either there are two modes for WEP. Either there is null security. By null security here I mean no security. So these stations, they don't even have to know the passphrase, right? So authenticate themselves by just sending, I want to associate, then fine, خلاص, associate, done. Okay? They don't need to know anything. Okay? So in that case, of course, the data transfer will not be protected, right? But of course, WEP came up with the concept of passphrase. The passphrase here is like some kind of a password, right? But this password is actually shared in the whole basic service set, which means that all these stations, they all share the same password, right? So at the beginning, WEP said, okay, so from this passphrase, we can generate directly pre-shared key. Directly, even without hashing. So at the beginning, they thought about a very simple mechanism. So they didn't even use hashing, right? But in order to make this a little bit secure, so stations, they use the pre-shared key based on the passphrase plus some initial vector. Okay? So the passphrase is actually shared between all the stations, right? And the initial vector is actually, it gets sent from the station to the access point. So what happens is that at the beginning, the station would say, so I want to request to associate with you. So the access point would say, okay, so authenticate yourself. Okay? So the station, what it does is that, because you are supposed to know the password or the passphrase, so what the station does is that it creates some kind of a puzzle with a pre-shared key, which is done using initial vector and the passphrase. And then it sends that puzzle with the initial vector to the access point. Then the access point would have the initial vector, and of course it has the passphrase, so it kind of generates the same pre-shared key, and it decrypts that puzzle, and it authenticates the station based on that. Very easy, very simple, right? What's wrong about this, or what makes this really breakable easily, is that the passphrase is shared between all the stations, right? There's no specifics about each station, and even the initial vector itself is sent in plain text. It has to be sent in plain text, not the password, of course, but the initial vector itself is sent in plain text. So that makes crypto analysis extremely easy. In fact, anyone can inject some thousands of packets to the access point, okay, with some initial vectors, and will be able to also sniff initial vectors from the current stations, and will use this huge amount of data to kind of predict the passphrase. So if you predict the passphrase, so what happens is that this pre-shared key, which is based on the initial vector and the passphrase, will be used as a seed for the RC4. Remember, RC4 is based on pseudo random function, right? صح? It's based on pseudo random function which generates the random sequence. This random sequence will be XORed with the data to provide the ciphertext. Vernam cipher, easy. Okay? So this is breakable by just, so what the attacker needs to do here is to read as many initial vectors as possible. Whether, and حتى even if the stations are not sending any initial vector, it can inject some fake data to the access point with some initial vectors to try to have some response from the access point to try to kind of predict or to guess the passphrase, and that can be done easily. يعني in Kali Linux, I think there is a small tool كده. I think it takes about 2 minutes to come up with a passphrase. يعني. Okay. So that's a WEP. Okay. طيب. So what they did in WPA بقى, WPA, which is like a software upgrade, as we said. So here بقى, the pre-shared key is actually specific to each station, which is based on hash function, okay, which is composed of the passphrase, of course, plus the initial vector, صح, plus the MAC address, the MAC address of the station, and the MAC address of the access point. Okay, so that created some kind of some security strength, a little bit. Okay, so it's hashed. You have some specifics about the access, the MAC address of this particular station, and so on. So that WPA was kind of more strong. Let's say we can break it in 5 minutes instead of 2 minutes, something like that. So, but still, it's still breakable, and that's why the use of 802.11i was kind of it's a must. Okay. But of course, as we will see, even with WPA2 or RSN or 802.11i are all the name for the same thing. So that came up with a standard which uses the concept of authentication through 802.1x, an extensible authentication protocol, and the back-end authentication server, which connects with IKE or TLS or something like this. But still, it has to be backward compatible with these protocols as well. And that's why you will see that RSN or 802.11i still backward compatible with WEP and WPA. ماشي? So any question about this? So of course, here it's the same thing. So you use the pre-shared key using RC4, and then you come up with the sequence, and that can be used to generate the cipher. In WPA2 بقى, okay, in WPA2, even after generating it's not called بقى pre-share key in that case, okay? It's called master session key, and we'll talk about this, okay? So after finishing the authentication process, which is here, it's a long process بقى, صح? We talked about it. To go through 802.1x and the EAP, and to go with the backend server. So there are lots of messages that get sent back and forth to authenticate. The result would be a master session key or a semi-permanent key, right? So this key بقى, it's supposed to be used, but in that case, برضو, what they thought about is not to use RC4. Why? Because RC4 was not strong from a security perspective. It's good from error resistant perspective, but it's not good from a security perspective. So what do you think would achieve the same objective with some security strength? Have you noticed this in the assignments? That's why I say this assignment is really important. Yeah, you're supposed to really understand so many things by doing this assignment, especially if you tried that hands-on yourself. When I finish it, I'll be able to tell you. So if you remember, when it comes to comparing the performance against the error control, there was another mode of operation
CTR.
that CTR?
AES CTR.
AES, huh?
AES.
Counter mode, yes, bravo عليك, yes, excellent, yes, you're perfectly right. So the counter mode achieves the same performance like RC4, but counter mode from a security perspective is a lot more strong. Okay, so that's why here in WPA2 they use the counter mode AES for confidentiality. Okay, instead of RC4. It's still, instead of encrypting, instead of generating بقى random sequence, لا, use AES to encrypt you encrypt the counter. You encrypt some counters, right? And then you generate sort of a random sequence which you can get XORed with the text. Okay, but doing it this way is a lot more strong in terms of security compared to RC4. Okay. So in WPA2, so they implemented these two major actually more than this, we'll see. The standard is really complicated. But these are the major things that have been introduced. So they have streamlined authentication using بقى 802.1x and EAP, and they have used the counter mode AES for confidentiality. ماشي كده? So this is the whole picture. So now بقى we'll dig deeper into the 802.11i or RSN or WPA2 standards. Okay. So we'll see that the standard here talks about this access control, which is done through the 802.1x. Okay. So 802.1x, as we said, provides the authentication from the access control, the network access control layer, okay, for multi-access LANs, if you remember from the previous chapter. So together with the authentication and key generation, which is done through the extensible authentication protocol, which provides the transport service to allow you to communicate with back-end server, which is responsible for authentication بقى, اللي هو through بقى TLS or TTLS and so on. ماشي? Using those two parts, so using the 802.1x and the extensible authentication protocol, the result here would be a master session key. ماشي? This master session key is the semi-permanent key that we can use to generate all the other keys. So why do we need multiple keys? Why do we need multiple keys?
Accessing different access points.
لا.
So what if
Why do we need multiple keys?
master session key gets hacked, compromised, so it has to be
No.
temporary, or to manage because each client should have a session key with the access point. virtual data.
Yeah, ما this is done يعني each, by the way, the master session key is for each station. It's exclusive for one station.
Here, both message authentication and also key generation for these two keys or multiple keys.
Well, yes, يعني we have one key for to provide confidentiality for encryption and decryption, صح? And we have another key for what? For Mac. صح؟ اللي هو المسج authentication يعني message authentication tag or message authentication code, right? Okay. And of course we may have other keys as well for generating like some kind of initial vectors or other things. طيب, so the main thing is to use confidentiality and data origin authentication. Okay. And integrity. Integrity طبعا is done through the signatures. Signatures we use by HMAC, SHA1 and so on, right? They don't need keys, okay? But the two main functionalities for which we need keys are confidentiality and data origin authentication, which is يعني ايه اللي هو الماك اللي هو message authentication codes, okay? So this can be done in two ways. And why two ways? Because this TCAP is what we call a temporal key integrity protocol. This TCAP is for backward compatibility. So this actually implements RC4. This uses RC4, okay, for data transfer security. Okay, for confidentiality, it uses a RC4. And actually for authentication, it does not use 802.1x ولا الكلام ده. It uses a passphrase, either null authentication or using passphrase اللي هي WEP or WPA. Okay, so this is for backward compatibility. Or we can use اللي هو يسموه counter mode cipher block chaining MAC protocol. اهي يعني انا برضه يعني اهي counter mode with cipher block chaining MAC protocol. Counter mode refers to the confidentiality part, okay? And cipher block chaining refers to the generation of MAC اللي هو message authentication codes, صح؟ اللي هي for data integrity and authentication. واضح واضح؟ Okay? So counter mode is used for data transfer. And for data transfer, we said that we need some error resistance, and that's why we use counter mode. But for MAC generation, remember that for MAC, for generation of MAC, for data integrity, okay, we don't need to support resistance for errors. In fact, this is used for integrity. صح? And that's why we use cipher block chaining. We don't use counter mode here, right? We don't need to have any error resistance. We use cipher block chaining because it has to be really, because it actually affects the integrity of data, right? And that's why for Mac we use cipher block chaining. If you remember, cipher block chaining was based on a chaining, يعني from one data frame to another and so on. So that actually strengthens the security even more. So that's why we need cipher block chaining for Mac generation, but for data transfer, we use counter mode, which is error resistance. ماشي كده؟ طيب, so this CCMP combines the confidentiality and the message origin authentication. طيب, so confidentiality is either for the case of TCAP is done using RC4, صح? And for the case of CCMP is done using the counter mode AES. So that's what we said, right? Integrity origin authentication, it uses طبعا احنا we have here MAC is composed of two things, صح? اللي هو the generation of the signature and then the authentication part, صح? So the signature part uses a HMAC SHA-1 or the HMAC MD5. Okay, this is for the signature. Okay, and for the data origin authentication, we have to buy for the TCAP. It uses some kind of message integrity code similar to the MAC, but again uses the pre-shared key to be backward compatible. For the case of CCMP, okay, we use بقى cipher block chaining with AES. ماشي؟ واضح ولا ماشي؟ واضح؟ Okay. And then the key generation. Key generation بقى احنا قلنا يعني here from these two we come up with a master session key. The master session key, okay, is going to be exclusive to one station with the access point, okay? And then the station with this master session key can generate by all other keys. It generates a bunch of other keys, and we'll talk here about explosion of keys. We'll see بقى يعني how many keys we need for that case. ماشي؟ طيب. So to generate this set of keys, we need some kind of a hash function. So they use the HMAC SHA-1, okay, to generate all these set of keys from the master session key. Okay, that's what we will talk about in the next few slides. So we need to talk about the set of keys that we generate from the master session key. طيب, so the process, so the phases where we have to go through in order to have eventually the protected data transfer are, the first thing is to do discovery. So in the discovery phase here talks about the fact that access points will split or broadcast the SSID. Okay. So the station will then have set of SSIDs. Whether this is done automatically or manually, the station needs to associate itself to one access point. So when it does that, okay, the process of association, okay, engages the authentication. Authentication here can be done using the three different ways that we talked about: WEP, WPA, or WPA2. Right? The result here will be either pre-shared key in the case of WEP and WPA, or master session key in the case of 802.11i. Okay? Is this enough to get us going? No. So we have to do key management. The key management here generates a set of keys, which we will talk about, okay, which can be used not only حتى for data transfer in unicast way. We have also multicast, we have broadcast. All of this have to be secure. So once we generate all these keys, only then we'll be able to do some protected data transfer. So we use the relevant keys to provide protected data transfer. So that's how these phases are done. Once we are done, we terminate. That's it. Okay, so understand all these phases?
Why can't we just simply use the master session key to encrypt the data? Why should we generate?
That's what we'll talk about in the next few slides. Phase here. Okay. Okay. So let's maybe have 5 minutes stretching, لأن starting from here يعني الدنيا هتسوق شوية. طيب, so we'll start to talk about the phases in the previous slide, بس in a lot more protocol handshaking details. So it starts with the fact that a station wants to associate itself to a particular access point. So it sends just a request. I want to get associated with you. Just a very simple request. So in that case, the access point will start to negotiate. The first thing will start to negotiate the security configuration. So if you are setting up your access point to use WEP or WPA or something like this, so the access point will send this information back to the station and ask the station to start to authenticate itself using one of these three ways. Okay. So the station will start to authenticate itself. So the first thing, this is the minimum, which is null authentication, and this is provided in 802.11i, as I said, for a backward compatibility. So the station will use the open system authentication request. So this actually uses null authentication, which means no authentication, or it can use the passphrase mechanism for the case of WEP or WPA. Okay, so this gets sent to the access point. The access point will respond back if it was able to authenticate the station either using null authentication or if it was able to decrypt the puzzle using the correct passphrase, in which case it can authenticate the station. So at this point, the station was successful in terms of authenticating itself. So now it sends back the authentication request, and this authentication request is needed now to establish the parameters. يعني some parameters بقى related مثلا to what channel to be used, things like that. Okay, so here at this point, the association could be done completely, right, based on the security mechanism that was communicated here. So if it's WEP or WPA, then at this point we're done, right? If it's WPA2, then these messages will be null authentication for backward compatibility, and then we'll start the phase of authentication using 802.11i, which will involve a 802.1x with EAP, okay, that has to go through the radius server or the authentication server. So this part here is where the authentication messages will be exchanged using بقى certificates, using يعني IKE, using TLS, using whatever. So this part here is where the actual authentication is done through TLS, TTLS, IKE, pre-shared key, or anything like that. ماشي? So once we are done with this, then this part, as we said, this part is based on whether we are using WPA2 or not. If we're not using WPA2, then this part will not be done. Okay? If it's WPA2, then we have to go through this phase. Here, the result here is that the authentication part is being done, which means that here we have either pre-shared key or master session key. But as we notice, still the control port A blocked. So why is not open? Why the port is not open at this case? We are done with the authentication, but we have to go through a. Once we come up with these, are we done? We have to go through a phase, another phase, which is ايه؟ لا هو خلاص authentication is done from both sides. خلاص كده authentication is done from both sides. Okay, so we generated the pre-shared key or the master session key. What else do we need to do? أيوة the key generation for the session keys بقى صح. Okay, so there is so that's why here you see the port is still blocked. Even here the port is still blocked. Okay, so we have to go through the next phase for key generation. طيب, so this explains this concept. So this summarizes this concept of controlled ports versus uncontrolled ports. So when we talk about controlled ports could be used for, and control port here could be a physical port if we're talking about Ethernet, wired access, or logical port in the case of wireless. For both cases, control port could be used for data transfer. Could be used for data transfer only if it's unblocked, right? Controlled معناها it could be blocked or unblocked, right? If it's blocked, cannot be used for data transfer. If it's unblocked, can be used for data transfer. طيب, uncontrolled port are used to exchange control information, but not to be used for data transfer, right? Which is مثلا the port. Yeah, from access point to the authentication server. From the access point to the authentication server, we call this port uncontrolled port because it can be used to transfer layer authentication messages. صح? But it cannot be used for data transfer. Cannot be used for data transfer. So this is the uncontrolled port. Okay? واضح كده؟ So the control port can be used for both, but it can be used for data transfer only if it's unblocked. Only if it's unblocked. طيب. Yeah, so this is the same slide again. I don't know why it's repeated, but anyway. As we said, the result is either pre-shared key or master session key. So the pre-shared key is done outside the 802.11i. يعني it's using بقى WEP or WPA. Okay? The master session key بقى is what we generate if we were to use the 802.11i going through the process of authentication with 802.1x and EAP and so on. Okay? طيب there is بقى pairwise master key. طب هو master session key وبعدين pairwise master key. طب why do we need to go from this to this? There is بقى يعني a reason which I had to يعني dig deeper in order to know why do we need to do this. The reason for this يعني focus بقى. The reason for this is that this master session key is the result of what? Is the result of authentication using different authentication methods, صح? Okay? Based on these authentication methods would lead to different size of key. Okay? So IKE, for example, the authentication would generate a master session key of size 128 bits, صح? But TLS generates a master session key of 256, something like that, right? Can we use different sizes of keys for data transfer? It has to be unified, صح? So what happens is that the pairwise master key, it's actually a result of a hash function based on the master session key together with the MAC of the station and the MAC of the access point. واضح كده؟ And by hash here, I mean the hash takes a variable size message and it generates a fixed size. Fixed size, right? واضح كده؟ So by doing this process, I make sure that the pairwise master key is now a unified key of fixed size that I can use from now on. ماشي؟ طيب. From this pairwise master key we generate what we call pairwise transient keys اللي هو session keys اللي هي temporary session keys. ماشي كده؟ So this pairwise transient keys is actually three different keys. It's not one key. It's actually three different keys, and we'll talk about each one of them. And these transient keys are now valid for one session or temporary. Okay? So after some time, we can in fact use the pairwise master key to generate other set of keys and so on if we need. ماشي? So we'll talk about the pairwise transient key and the three different keys. So the pairwise transient key is composed of three different keys. The first two keys, okay, are not used for data encryption or confidentiality or anything like this. It's not for data خالص. We'll see the key confirmation keys, it actually supports the integrity of the control messages that get sent from the station to the access point. And we'll talk about this in a minute. And even the key encryption key. So we have the key confirmation key and key encryption key. Key encryption key here is the key that is used to communicate other keys to the station. And we'll talk about when do we need this. Okay? In other words, those two are not used for data encryption. Those are used for other purposes, which we will talk about, very specific purposes. This is بقى the temporal key is the one that we use for encrypting data بقى. ماشي؟ This is the provide the actual protection of unicast, unicast user traffic. Unicast user traffic. Because for multicast and broadcast, something else. We'll talk about this. ماشي كده؟ So pairwise transaction key are 3 keys. Key confirmation key, key encryption key, and the temporal.
Doctor, the
For the-
temporal key changes every session or it is fixed, it's not changing?
All the 3 keys are per session. So after some time you can renew them. You can generate another set of keys. ماشي؟ بس still based على ال pairwise master key. Pairwise master key. طيب, so ماشي, so until now we have been able to generate keys to protect unicast transfer. Okay, but definitely in wireless LANs we send also multicast and broadcast data. So when we send broadcast or multicast data, we need to send it using a key which should be shared between multiple stations. صح? So this key needs to be known by multiple stations in that case, not by just... So as we said, pairwise master key or the master session key is exclusive for one station, right? But for broadcast and multicast, we need a key which is shared between... So this key is what we call a group master key. So again, from the pairwise master key, we generate also the group master key. Okay? طيب. From the group master key كمان, we have to generate what we call group temporal key. What is the difference between the group master key and the group temporal key? The group temporal key is temporary, but here it doesn't change with time only. No, it has to be changed every time a node gets away or comes into the group. So any kind of change happens to the broadcast group or the multicast group, you have to renew this. Why? Why? Because assume that now we have like 3 set of stations or 4 set of stations, okay? And all of them, they use the same group transient key, right? And this station has moved away, okay? If I still use the same group transient key, this station might perform an attack because it has deassociated itself, but it can inject some messages, malicious content in the wireless LAN through knowing this group transient key. So every time a node moves away or a node comes in, I have to renew the group transient key. So the way I do this is to generate group transient key from hash function based on the group master key. Plus طبعا other parameters which usually have to do with the MAC addresses of the stations participating in this group. And the access points, yes. ماشي كده? Alright, so this is the difference between the group master key and the group transient key. Here is changed every time a device leaves the network. So that's the most important thing. So it's temporary, but here بقى, not only based on time, based on event as well. If a node goes out, node comes in, it has to be renewed. Any questions so far?
An example, what type of data that we should transfer through broadcast or
كتير جدا. كتير. Sometimes يعني حتى protocol messages have to be sent multicast and broadcast. كتير جدا. طيب, so now بقى we talk about the key management phase. In the key management phase بقى, still remember the port was still blocked. So the key management phase here starts with the fact that first the station delivers what we call بقى the nonce, right? Because now we need to generate the pairwise transient key, okay, from the pairwise master key, okay. Usually we use two things. We use the MAC of the station, here the MAC of the station and the MAC of the access point, and what we call nonce. Nonce are similar كده to the initial vectors or to some, it's like some arbitrary randomized sequence that also strengthens the key generation process, okay? So there is a nonce that gets generated by the access point and it gets sent to the station, okay? The station will then say, okay, so I will also generate nonce locally. So here this nonce is also based on the station and the access point. So now the pairwise transient key is a result of a hash function which includes pairwise master key, the MAC address of the access point and the base station, and the nonce of the station and the access point. Okay, so first the access point will send the nonce, and the station will generate will be able to, in this case, to generate nonce locally at the access at the station point, and then generate the pairwise transient key. Okay, and then it sends the nonce of the station so that the access point would do the same thing, right? Okay. ماشي كده؟ طيب here بقى this message confirms the authentication by using what we call بقى a key confirmation key. Key confirmation key is used to perform authentication part here for the station, which confirms that the pairwise transient key has been generated correctly. Okay? Okay, كده? So here we use the key confirmation key to generate some kind of a MAC code that the station sends to the access point that confirms that the pairwise transient key process has been generated successfully. In order to confirm this, we use what we call a key confirmation key. The key confirmation key, we use it to generate a MAC, and then we send it to the access point. If the access point can verify this MAC, this means that station is confirmed, the pairwise transient key process has been confirmed. So at this point only, remember, at this point, we have the pairwise transient key, okay, which is valid for data transmission for unicast. Okay, for unicast between the station and the access point only. ماشي كده؟ And here we see control block is unblocked for unicast transfer only. Because at this point we have been able to generate and verify the pairwise transient key. خلاص? So that's done. So what's remaining now is that we also have to generate the group master key with group transient key. Okay? And of course here, by the way, here برضو the group master key has been generated, because the group master key is for multicast and broadcast, but what needs to be done is to generate by the group transient key. Okay? So here بقى the access point delivers a new group transient key. This group transient key is based on the group master key, and it gets sent to the stations. Okay? How do you think this is done? Can we send this group transient, because it says delivers the group transient key. Can we deliver a key in plain text? What do we do here? لا مش هاشing. لا هنا hashing is not enough. لا here this message is encrypted. Encrypted using ايه بقى؟ ها؟ Can you guess? بالظبط برافو عليك. يس بالظبط اللي هو الكي انكريبشن كي اللي هو الكي التاني. فان احنا قلنا pair wise terms and keys ما صعب ان انتوا تحفظوهم دلوقتي يعني، بس يعني you will be able to memorize them. So the key the pair wise terms and key is composed of 3 keys. Key confirmation key, which we have used here to verify the process of by generating this MAC, صح? And the key encryption key. Key encryption key is used to encrypt this message, okay, that contains the group transient key. This part is really enjoyable because I can ask you thousands of questions. I can ask you thousands of questions here. Okay, so the key encryption key is used to encrypt this message, okay, which contains the group transient key. So in that case, remember here I have to deliver it one by one. I have to send it. I use station 1's temporal key, key encryption key to send the group transient key, and then send it to the other one, send it to the other one. Once I finish all of this, then all of them would contain the group transient key. They can use it for broadcast communication. Okay, and each time one of them leaves or comes in, I have to do all of this. I have to go back, generate another group transient key, and deliver it to all of them. Then they can communicate. ماشي? This is what I was talking about when we talk about if we use this for ad hoc بقى, some nodes leave and come in and stuff like that, you have to use some kind of prediction to know when do you have to communicate these types of keys. Managing these keys becomes really يعني a very complicated process, especially for ad hoc networks اللي هي multi UAVs يعني for ad hoc networks. Okay, تمام كده؟ So this message would be encrypted if I have the pairwise transient key, or specifically the key encryption key. I will be able to decrypt this, and then I will provide the confirmation that I have received. So this has to be done for all the stations. ماشي كده؟ فالحمد لله, so we have managed to provide the complete authentication for unicast and for multicast and broadcast. So we either use the TKIP protocol, which is for backward compatibility with WEP and WPA, and in that case it's based on RC4, or we can use the counter mode cipher blockchaining MAC protocol for the case of 802.11i. So this provides this provides the pre-shared key or the master session key, from which we generate the pairwise master key, which can be used for providing message integrity and confidentiality. So to generate the pairwise master key from the to generate the pairwise transient key from the master key, as we said, we use some kind of hashing or pseudo-random function, and in that case the standard recommends the use of a HMAC with SHA-1 for the hashing. It's just recommendation. Yeah. So that's the summary for this part. So in this part, as we said, it's divided into 3 parts. The first part, we talked about the intrinsic characteristics that exist in wireless that makes wireless really should have a special treatment in terms of security. And then we talked about the Wi-Fi alliance and the history of the Wi-Fi and the terminology of basic service set and so on. And then in the third part, we talked about the security protocol, whether WEP, WPA, or WPA2, which is 802.11. Okay?